Hello everyone. So let's start solving the next 5 set of organic questions from the JAM 2018 question paper. Right. So the first question says the sequence of 3 steps involved in the following reaction, following conversion is. So we can see here there is a benzene ring, and in the product we are having on benzene ring 2 alkyl groups. Let us look at the position. Position of both of them are at the meta position. So first step will be, of course, it will be either Friedel-Crafts acylation or Friedel-Crafts alkylation, and then second will be again Friedel-Crafts acylation or alkylation. So the thing is, if the product has to be found meta, that means the initial should be addition of electron withdrawing group. So of course it cannot be Friedel-Crafts alkylation, because alkyl group is electron donating group, so it will be ortho and para directing. So it will be Friedel-Crafts acylation reaction, so that you get something like C double bond O, so that it is electron withdrawing group, and then you can put on the meta position, right. So very clearly the answers possible right now are either B, C or D. So let us look at them. So it says Friedel-Crafts acylation followed by Friedel-Crafts alkylation and then reduction. This looks good to me. If it is Friedel-Crafts acylation followed by reduction, if I reduce it, it becomes again alkyl group, then it will become again ortho para directing. So I can definitely neglect of these 3. Let us look here. So this is Friedel-Crafts acylation followed by reduction. We can do this also, but there is no point. We would rather do this one, but yeah, we can do this also. We have to use 2 equivalents of reducing agent. So this is pretty simple now. So you take a benzene molecule and react it with acyl halide. So here it will be propanyl chloride in presence of AlCl3. So you get at the you get electrophilic substitution reaction. So I hope everybody knows this. Friedel-Crafts acylation is electrophilic substitution reaction, where AlCl3 acts as a Lewis acid catalyst. So it helps to activate, so that the Cl minus leaves. It helps them making Cl minus a better leaving group, and it also creates more positive charge on this carbon, so that benzene goes and attacks here, and then this Cl minus leaves as AlCl4 minus, right, and you get this. Now it is meta reacting. Why? Because we can see this, there is a C double bond O, which helps in withdrawing electron by minus R effect. So because it is electron withdrawing group, we can see that both ortho and para position are deactivated, they have positive charge. Now we are talking about electrophilic substitution reaction. So electrophilic, whenever you think about electrophile, think about E plus. So you need more of electron. So because electron withdrawing group, you are getting positive charge on ortho and para, and therefore relatively there is more electrons in meta position, therefore attack happens at meta positions. You just react with alkyl chloride, and again in presence of AlCl3 it will give you this. Then you have to do Clemmensen reduction of Wolff-Kishner reduction. So this reduction reduces the ketone or aldehyde into alkene. So it reduces, it becomes CH2 this. So the answer is B. Next question. On reaction with NaNO2 and HCl. So we know whenever NaNO2 and HCl they react, they give you HNO2, nitrous acid, okay, and nitrous acid with amines forms diazonium salt. This you have to know, okay. So this is the nitrous acid, which on the following amino alcohols will yield compound P. It is saying this is the product which is formed. They are asking which are the reactants which will give. So A, B, C or D. So basically all of them are having amino group NH2, all of them are having amino group NH2 and OH is there. So first step will be of course diazotization, and then it will be kind of pinacol-pinaclone rearrangement, where the ring contracts, rearrangement happens because of this oxygen, because this becomes very good leaving group. The thing is, let us go step by step. The first step is NH2 reacts with NaNO2 HCl to give you N2 plus Cl minus. So first what we have to do is we have to convert, this is anyway in chair form, so there is no issues. So let us look. once this becomes N2 plus Cl minus, if it has to leave, okay, and the rearrangement occurs, then the bond which moves should be anti-periplanar to each other. That means this bond has to be parallel with the alkyl group which is moving. You see this bond, this is down, equatorial position, this bond is down. So here arrangement, rearrangement can occur, this can go and attack here. Here what happens is there is a NH2 on axial positions. To anti-periplanar to it will be this hydrogen. You see here, these two are parallel to each other, this bond and this bond are parallel to each other. So if at all anything can happen, that can happen is hydrogen will move. So we will not get the ring contraction which we want. So definitely A and C cannot be the, A and D cannot be the answer, because in both A and D the NH2 is in axial position. The NH2 is in axial position. So if NH2 is in axial position, alkyl group will not be migrate, because there is no alkyl group in the ring. There is no part of the chain in the ring which is anti-periplanar to axial. So very clear cut answer is B and D. Let us look at it, what happens. So you react this with HNO2, that is NaNO2 plus HCl, it forms a diazonium salt N2 plus Cl minus. Now N2 plus is a wonderful, most wonderful leaving group, because once it leaves it becomes very stable. N2, you know, nitrogen molecule is very stable because it has triple bond. So it's a kind of pinnacle-pinnacle arrangement. So this one goes here. Basically lone pair of oxygen comes and then later this bond comes in. So you can write together, and because this bond and this bond is parallel, so this bond migrate, goes up, and you get here. Now let us look what happens. This tertiary butyl is above the plane, so I am making it towards the viewer, and this CHO, see there is a hydrogen which is on top, okay, there is a hydrogen which is on top. So this goes and attacks here, so this will be down. So you can see that H is on top and CHO is down, so CHO will be away from the viewer. Similarly, let us look here. Here again same, pretty much same, only thing is OH is in axial position, this moves here, this moves here, and then again we are getting this. So this hydrogen which is on top remains on top, this CHO which is forming is down, so it is away from the viewer, and this tertiary butyl which is above the plane, you can look here, this is above the plane and this hydrogen is below the plane. So tertiary butyl is again towards the viewer. So B and C are the right answers. So they have very clearly given the stereochemistry of the product also. Fine. Moving on to the next question, question number 13. The correct statement about carbene is or are. So it is multiple, like it can have more than one correct answer. So carbene is a neutral species. Of course, carbene is a neutral species. It is electron deficient, but it is still neutral. So see here, they have 6 electrons. 1, 2 and 2 bond pairs are there. 2 plus 2 plus 2, 6. They are electrophile, but still they are neutral. Okay. Second is carbene is intermediate to Curtius rearrangement. No, Curtius rearrangement, the intermediate is isocyanate. Carbene can insert in both sigma and pi bond. That is perfectly right, because they are very reactive. So it helps in breaking the bond and getting insertion. So this is also right. Carbene is generated on from amines on reaction with nitrous acid. Just now we looked at it. So nitrous acid, it forms N2 plus. Nitrous acid is NaNO2 plus HCl, that gives you NaNO2. So when it reacts with amine, it gives you N2 plus. So N2 plus, when it leaves from a carbon, you don't get carbene. What you get is a carbocation. So D is also not the right answer. So the answer is A and C. The compounds which show positive haloform test is and are. So haloform test, mostly we do iodoform test, we react with I2 and NaOH. So basic criteria is for iodoform reaction, there should be a ketone and next to it there should be a CH3. So very clearly this will be the right answer. Okay. And apart from that, what it says is, even if something like alcohol is there, even if something like alcohol is there, instead of C double bond O, if OH is there, it can get oxidized in the first step to ketone, and then again if CH3 is there beside this C double bond O, then it can also undergo oxidation. So very clear this is what happens. So what we need is a methyl ketone or secondary alcohol where CH3 is attached to the carbon on which OH is there. Okay, again secondary alcohol because you want it to form ketone. So in the first step X2 is halogen. So generally I2 we use iodine plus OH minus. So it gets oxidized in the first step, it forms methyl ketone. Remember, this is not what is undergoing reaction. The reaction which undergoes haloform is methyl ketone, but it gets oxidized to methyl ketone and then it gives you this, and then you get CHI3 which is the iodoform, CHCl3 will be chloroform, things like that. So here what are there? A and B. We can see here there is a methyl ketone, here again it is a methyl ketone, alcohol is not there, and C and D does not have that thing. So the answer is A and B. Moving to the last question, it says tetrapeptide that gives the following product on reaction with Sanger's reagent followed by hydrolysis. Okay, so Sanger reagent, this part is actually Sanger's reagent, NO2, NO2, and here F is there. Okay, so it is a 2,4-dinitrofluorobenzene is Sanger's reagent. What does it? It reacts with the N terminal of the peptide and then finally it hydrolyzes. So this part is the amino acid of the peptide which it hydrolyzes. So we can see here there is a hydrogen here and CH3 here. Very clearly this is alanine. That means it is breaking the alanine from the N terminal. Okay, and when we write any peptides, when any like dipeptide, tripeptide, tetrapeptide, anything, we always write C terminal on the right, N terminal on the left. And as I said, N terminal means this part will have NH2 free, this part will have NH2 free, the left part, and the right part COOH is free, and that is why we call it C terminal, right? C terminal. Just now what I said is the Sanger's reagent interact with NH2. So NH2. So what we need is basically you can see that alanine is coming. We want at the left terminal alanine. So answer will be A and answer will be also D. Let us look at it. So this is the thing, A, we are having alanine and then glycine, leucine, phenylalanine. So this is the C terminal, COH is there, this is the N terminal. This react with Sanger's reagent. So now you can see this fluoro is there, which gets lot of positive polarity on this, so that nucleophilic attack can happen on this, and then nitro groups are there which stabilizes the negative charge when attack happens, and therefore it will undergo what is called as SNAR, nucleophilic aromatic substitution reaction. This nitrogen lone pair, sorry, yeah, this goes and attacks here. It is not one step reaction, please remember, this negative charge will be delocalized, then it comes back again, and then this F minus leaves and you get this thing first. Okay, and then once you hydrolyze, this opens up and then you are getting this alanine attached to the Sanger's reagent. Therefore very clearly the answer is A and D. So that's it for today. Thank you very much.